Good morning students. My name is C.H. Devi. I work as chemistry lecturer in Dr. Lankapalli Bullai College. Today we will discuss remaining special reactions of phenols. Now in previous classes already some special reactions are discussed. Let us continue. And fourth special reactions of phenols is diazonium coupling. Diazonium coupling. Now coupling it diazonium chloride with phenol to form orange dye product. Now you take benzene diazonium chloride. This benzene diazonium chloride is treated with phenols. Now this benzene diazonium chloride is treated with phenols under acidic conditions by the loss of HCl. To form para-hydroxyazobenzene. These are the para-hydroxyazobenzene. These are orange dye precipitate. These have orange dye precipitate. Now what is this name? Benzene diazonium chloride. In diazonium coupling means coupling with benzene diazonium chloride and phenol to form orange dye precipitation. Now another special reaction, Fries rearrangement. Another fifth special reaction is Fries rearrangement. In Fries rearrangement means you take phenyl acetate is acting as a reactant of Fries rearrangement. Phenyl acetate is acting as a reactant of Fries rearrangement. Now this phenyl acetate is treated with anhydride aluminum chloride under heat conditions to form orthohydroxy acetophenone and para-hydroxy acetophenone. In this one we observe this acyl group is migrate from ortho position and para position. In Fries, what is Fries rearrangement? In phenyl acetate is treated with anhydride aluminum chloride under heat conditions to form ortho and para products. Now let us discuss a suitable mechanism of Fries rearrangement. Now in this one you take the mechanical structure of phenyl acetate. Now this phenyl acetate is treated with aluminum chloride. This phenyl acetate is treated with aluminum chloride. You know that aluminum is the third group element, so that it has an empty box in front side. This oxygen also having two lone pairs of electron. This lone pair of electron is negative nature. So this lone pair of electron is adding at this empty orbitals of aluminum. That means a new bond is formed in between oxygen and aluminum to form and O C double bond O CH3 O C double bond O CH3, and this oxygen also a new bond with aluminum. This aluminum is gold bonded with 3 chlorine atoms. Now this oxygen is carrying a positive charge and aluminum is carrying a negative charges. Now in this compound is involving in further reaction. Now this nullifying of oxonium intermediate, this C and O bond is shift towards this oxygen side. This C and O bond is shift towards oxygen side by the elimination of C double bond O CH3 azolium ion, acyl cation or azolium ion intermediate is observed, and plus this aluminium negative charge is nullified by the loss of chloride ion. Totally the product is benzene and oxygen. The oxygen is bonding with aluminium chloride. Now this compound is involving in acyl cation. Two products is observed. One is ortho attack product, another one is para attack product. And ortho attacking product. The mechanism of ortho attacking product. Now you take phenol aluminum chloride is treated with acyl cation. And listen, this oxygen also having two lone pairs of electron. This one lone pair of electron is shift towards benzene ring side, and then immediately one double bond is shift towards ortho carbon side. This ortho carbon is having negative charge. Immediately this negative charge is bonding with this acyl carbocation. That means a new bond is formed in between acyl carbon and ortho carbon. And new bond is indicating thick lines, and C double bond O CH3 and double bonded and AlCl2. Now this oxygen is carrying positive charge. Now this compound is involving in further reaction. This orthohydrogen is involving in reaction to this CH bond is shift towards this carbon side. Immediately this double bond shifted to oxygen side. Then this oxygen positive charge are neutralized. The product is benzene and ortho AlCl2, and ortho carbon is bonding with C double bond O CH3. Now then this compound is treated with hydrolysis. Now this compound is involving in further reaction with hydrolysis. This OAl bond is involving in reaction because this OAl bond is weak bond. Due to this reason, this OAl bond is involving in hydrolysis. This ionization formation of water molecule is H plus and OH minus. Now this OH minus is adding at this aluminium and H plus is adding at this oxygen side to form orthohydroxy acetophenone. Product. And the byproduct is aluminium hydroxychloride. Byproduct also observed. And let us discuss para attacking. Now again you take the product OAlCl2. Now this compound is treated with acyl carbocation. Listen, this oxygen also having two lone pairs of electron. One lone pair of electron is shift towards benzene ring side. Now immediately this bonds is involving in delocalization, and para carbon is carrying negative charge. Now this para carbonium is bonding with acyl carbocation. That means a new bond is formed in between para carbon and acyl carbon. The product is, again you write benzene ring and double bond OAlCl2. This oxygen is carrying positive charge, and also this para carbon is newly bonded with azelaium cation. Now this compound, this oxonium compound is involving in further reaction. This para hydrogen involving in this reaction. That means this CH bond is shifted towards or involving in delocalization. This O positive charge are nullified. OAlCl2 and para carbon is bonding with acyl group. Now again this compound is treated with or involving in further reaction on hydrolysis. Now ionic formation of water molecule is H plus and OH minus. Now this OAl bond, this weak bond is involving in hydrolysis to form para-hydroxy acetophenol. Para-hydroxy acetophenol. These are the para-hydroxy acetophenol. And the byproduct is aluminum hydroxychloride. And the byproduct is aluminum hydroxychloride. In Fry's rearrangement, you take acetophenol. Now this acetophenol is treated with anhydride aluminum chloride under heat conditions to form orthohydroxy acetophenol and para-hydroxy acetophenol. Another special reactions of phenol is pinacole-pinacolone reaction. Pinacole-pinacolone reaction. This reaction is very important reaction as an exam point of view, has 5 marks. In pinacole-pinacolone reaction, we observe group migration. In this reaction, you take glycol acting as a reactant. Now, this what is this name? Pinacole. Now, this pinacole is having 2 hydroxy group. That means the basic structure of pinacole is glycol. Now, this pinacole is treated with diluted H2SO4. That means under acidic conditions to form pinacolone. That means alcoholic functional group is turns to ketone functional groups under pinacole-pinacolone rearrangement. Now let us discuss a suitable mechanism of pinacole-pinacolone rearrangement. In this one, first you take pinacolone reactant CH3, C, CH3 and OH, C, CH3 and CH3 and OH. Now these are the pinacole. Now this pinacole is having 2 hydroxy groups. Now each oxygen is having 2 lone pairs of electrons. Now this pinacole is treated with under acidic conditions. You know that all acids are easily gives H plus ions. Now this one lone pair of oxygen is abstracting this H plus ions to turns to OH2 plus CH3, C, CH3 and OH and again C, OH2 plus CH3 and CH3. Now these compounds are unstable. Now immediately this OH2 group is elimination by the formation of water molecule to form carbonium intermediate. To form carbonium intermediate. Tertiary carbonium intermediate. Now this compound is involving in further reaction. Now this compound is involving in 2,3 methyl shift. Methyl shift. That means, now let us giving the numbering 1, 2, 3, 4. That means this second carbon also having 2 methyl group. In one methyl group is shift towards, one methyl group is shifts from second carbon to third carbon. That means one methyl group is migration from second carbon to third carbon. In this one, this compound is involving in rearrangement. That means 2,3 methyl shift is observed to form CH3C plus and OH and CH3 and CH3 and CH3. Now also this compound is involving in further reaction. Now this OH bond is shift towards carbon side. Immediately this carbon positive charge are neutralized by the elimination of H plus ions. By the elimination of H plus ions to form CH3 and C double bond O, C, CH3 and CH3 and CH3. Now this alcohol functional group is turns to ketone functional group. What is this name? Pinacole-pinacolone. Now in pinacole-pinacolone rearrangement, we observe 2,3 methyl migration. That means rearrangement is observed. Now and also alcohol functional group is turns to ketone functional group. In pinacole-pinacolone rearrangement, you take glycol is acting as a reactant in this reaction. Thank you. Thank you for listening patiently.